is 10th of August, aka my happy birthday. So I decided to make a video on the topic which I like the most, and that is, what is time? This may seem a very dumb question to answer, but it is way more complicated than that. 2500 years ago, there was a guy called Aristotle. And you know who Aristotle is, right? He is basically the teacher of Alexander the Great. So he said, time is the unknown of all unknown things. Pause the video right now, go on Google and search what is time. Google will show you time is entirely a different dimension, which makes things even more complicated. We know that time did exist even before clocks and watches were invented, and it always goes from past to future, and this thing is known as arrow of time. Nah, not here, over there. It looks much better over there, right? Okay, so this thing is called arrow of time, but this is a basic information regarding time, nothing too special. So if we want to understand time, we need to understand three things: light, classical relativity, and special relativity. Number one, light. So in 1865, there was a guy called James Clerk Maxwell. Not Glenn Maxwell, James Clerk Maxwell. This image is wrong. This guy, yeah. So he said that light is nothing but electromagnetic radiation, and it travels at the speed of 186,000 miles per second. Concept 1, over. Moving on to concept 2. Concept 2 is classical relativity. It says everything is going relative to each other. And what I mean by that, I'm going to show you an example. So imagine this is train A. This train is traveling at the speed of 60 kilometers per hour, and a train B is traveling at the speed of 40 kilometers per hour. So the speed of train A for train B will be 20 kilometers per hour. How exactly? Because 60 minus 40 equals 20. Because as we know, everything is relative to each other. And now we bring another thing in this. Imagine a train C. So a train C is going at the speed of 20 kilometers per hour. So the speed of train A for train C will be 40 kilometers per hour. So as you can see, speed actually varies. Okay, so what actually happens here is, it is going for 60 kilometers per hour, but for whom? I said train A is going at the speed of 60 kilometers per hour, but relative to what? Relative to the objects which are stationary, which have no motion. Because the object which is in motion, the speed of train A will differ. And yeah, if you made it till here without any confusion, congratulations and best of luck to you. Because this is the point where things start to get a bit too messy. Not that messy, this messy. Okay, concept number 3, special relativity. So if this sentence is true, that everything is relative to each other, then the speed of light is relative to what? This question baffled each and every scientist of that time. They were like this: what? Who is right then? Is Einstein right? Maxwell wrong? Who is right and who is wrong? So they were like this. Then Einstein came again with his crazy hairs and said that, see, light speed is same for each and everybody, because it is the fastest thing in the universe. And yeah, I want to make something really clear here. Einstein's each and every equation say that speed of light is constant for each and every observer, right? And if someone in next 100 years or next 50 years, say, or in any given time, if someone finds out that speed of light is not constant and is varies, whole Einstein's equation, Einstein's theory, Einstein's idea will be proved as wrong. Yeah, because these things are known as postulates. And what are postulates? So before making any theory, we need to make an assumption about that theory, which may or may not be true. But Einstein's equations are based on speed of light. And what do I mean by that sentence? I mean to say that Einstein's equation, Einstein's theory, Einstein's ideas, everything about general relativity, special relativity, and everything you learned so far were based on the thing that speed of light is same for each and every observer. The speed of light is same on Mars. The speed of light is same on Saturn. You get me, right? To specify his explanation that light is constant and same for each and every observer and it's the fastest thing in the universe, he came up with a very special thing. To that special thing, we know what gravity is. And that diagram is known as space-time diagram. Like this. You see right here? Wanted to make speed of light constant, he needed to get all the two dimensions in it. And what are those two dimensions? Space and time. And as we know that time itself is another dimension, he mentioned that space-time is 4D. And that space-time diagrams explain how gravity actually works, which is not according to Newton's laws, but this is how gravity works. And yeah, if you want to understand how gravity works, you can click here on the I button, tag button, I think, whatever it is. Or you can go in the description and there's a link of that gravity video. Or if you're too lazy like me, who doesn't want to click here and there and here in a running video, you can get that video on the end screen. So how does this space-time concept actually work? So space and time are bound together in a fabric called space-time. Massive object creates a bend in that space-time. So see, this guy is actually traveling from past to future, right? Now, this guy isn't traveling from past to future. Knew about time? Was like everything goes from past to future. It does not work like this, guys. I mean to say that if this guy is going from his past to future, a third person is saying that he is going from past to future. But assume I am that guy. He personally does not feel that he is going from past to future. He is moving through present every time. Because past was once your present. Present is your present. And future will be your present. Oh no. This is where his videos start to get a bit boring. Whatever we have learned so far only deals time with motion. This is a very great statement. Not a great, but this is a very important statement. Whatever we have learned about time only deals with motion. Time is generally, or 99% of time, the formula which we use, everything we refer to time is based on the motion of that object. We are not actually able to figure out what is the nature of time. We are not able to figure out how time actually works. We know what time is in a very blurry vision. We may have conquered moon. We may have planned to send humans to Mars, but this is the first thing that humanity should do. Understand time. And I'm not saying that people are not interested in this concept, but as for we go, this concept gets too blurry. We have no idea. So did time even exist before the Big Bang? We have theories and many people say that time was created after the Big Bang. But we do not have any proof of that. So until and unless we know when time was created, we cannot understand time in a deeper sense. In 1971, there was an experiment conducted to check Einstein's theory of relativity. Scientists doing the experiment took two planes, one which was stationary, and the other was set to move around the Earth. And the result of that experiment were pretty interesting. We came to know that Einstein was really correct because the time taken by the moving plane was not matching the time taken by the stationary plane. The stationary plane took more time as it was not comparing itself with the speed of light. It was stationary. Well, now do not bring that concept that Earth moves, solar system moves. It was in most of the sense stationary at that particular moment. And now, again, there is a Russian cosmonaut who actually time traveled. Yes, he is the only human to time travel. This is a bit of overacting. He is the only human to time travel. Okay, and if you want to check out that video, you can click here, link in the description, and you'll get that on the end screen. The question arises, do quantum particles take time? Do gluons take time? Do Higgs particles take time? But the main thing is, do photons experience time? Because photons is something which make the light and they go and speed up light. So do they experience time? The answer is, we have no definite answer. That is true, guys. We have no definite answers to these questions. Yeah, there are theories, there are some people arguing about it, but till now this has not been exactly proved that do photons experience time. Come to the conclusion of this boring, unedited episode. And that conclusion is Einstein was like, he was too into time stuff. And he said that time is not absolute because time can differ if person is moving at the speed of light or is moving at the 99.9% the speed of light or whatever it is. Time differs, and I've given right examples for it. And yeah, you can watch the two videos and the end screen. So why time is a different dimension? Well, it has too many properties that we don't know, and many properties of time are still unknown to us. So that's why scientists didn't want to bang their head on time concept. Einstein has made so many theories. Why I need to understand time? Rather than that, why don't focus on simple concepts such as how motion work, how geodesics work, or how thermodynamics work? The situation of the scientist. And yeah, that excludes Neil deGrasse Tyson, Stephen Hawking, Mikio Kaku, Albert Einstein, Brian Greene. And yeah, that actually excludes me because I like time concept. I like to talk about time. And yeah, if you've enjoyed this video, but I don't think somebody actually has made this far, but I need to say that, right? Because who knows, there is one person who made till here. So yeah, if you understand the concept of time, if you like this unedited, unscripted, it's not actually unscripted, I have the script here. So if you like this unedited, boring video made by this guy, so you can think of subscribing, huh? I won't take much of your time, don't worry about it. So here's the end screen, guys. Yeah, on my hand. Remember, time is nothing but a stubborn illusion. Ha ha ha.